So today's notes is all on factoring for the do now. I want you guys to find the greatest common factor, GCF, of A, B, and C. Pause the video, play it once you're done. So for A, the greatest common factor, I know 3 and 5 are common factors, but the greatest common factor of 15 and 75 is just 15, because 15 divides 15. 15 divided by 15 is 1. And 15 also divides 75. 15 times 5 is 75. So our greatest common factor for A is 15. Looking at B, we have variables and numbers here. So let's first look at the coefficients, the numbers. These don't, it looks like they would have a common factor. They actually don't. I guess it would be 1, but we don't need to write that for now. And now let's look at the x's. We have x squared, we have x to the 7th, and we have x to the 5th. So the GCF here for the x's is going to be the lowest degree. So it'll be x squared. And C, we have to first look at the coefficients of 36, the 168, and the 120. GCF there should be 12. And then now let's look at the x's. We get, a's, a to the 6th, a to the 9th, a to the 7th. Lowest exponent there for the a's is a to the 6th. And then let's look at the b's, b to the 19th, b to the 12th, and b to the 15th. That would be b to the 12th. So that would be our GCFs for A, B, and C. So today we're going to be factoring. We're going to be doing factoring out the greatest common factor, factoring a trinomial, and also factoring difference of two perfect squares. So I'm going to do, this should be reviewed, so I'm going to do the next one with you guys, and then I'll have you do the last 3. So when you look at 4x plus 22, factoring is really just the opposite of distributing. You're dividing out a common factor. So we have 4x and we have 22. Our GCF here is going to be 2. If you don't find the GCF here, you can always figure it out down the road. But this is also the only common factor. So when you take out 2, what you want to do is really just you're dividing every term in that binomial here by 2. So when you take out 2, you are left with 2x plus 11. And if you guys want to check, this is a nice thing about factoring, is that you can multiply it back in to make sure it's the same thing as the expression we're trying to represent. And it is. Look at that. Same exact thing. So the factored form of 4x plus 22 would be 2 times 2x plus 11. So I just want you guys to pause the video and try the next 3. For the second one, our GCF of 8, 32, and 72 is 8. And then take out the h to the lowest degree, because everything has an h, so it'll be 8h squared. And what's left over is h squared minus 4h plus 9 when you divide that out. And for that third one, let's look at the numbers. The GCF there is 3, x to the 4th, and everything has a y, and the lowest degree of y there is y to the 5th. So when you take that out, you're left with 2x squared y squared minus 3x to the 4th plus 6y to the 4th. Now, this last one is a little bit different than the other two. This involves factor by grouping. The greatest common factor here, let's zoom in on it. The greatest common factor here, I think factors multiplying, is x plus 6, because that's in both parts. So we want to factor out the x plus 6. And when you factor out the x plus 6, what we're left with is x squared minus 8. And let's make sure there's anything else factorable there inside the set of integers. No. So that would be our answer. Let's go to the next page. So when we have a trinomial in the form of ax squared plus bx plus c, and our lead coefficient a is equal to 1, there's a shortcut if it's factorable, to factor this. So what we would want to do here is we always want to look for the numbers that multiply to our constant. So multiply to 15 and add to the coefficient of x. So that would be 8. So you can list a bunch of numbers that add to 8. You can go on an infinite amount of numbers that add to 8. But multiply to 15 for integers, well, we have, if we look at the factors, we have 1 and 15. We have 3 and 5. They're multiplying to a positive, adding to a positive, so that means both of our factors are going to be positive. And then which two factors there add to 8? Well, it's 3 and 5. So our factored form is just going to be x plus 3 and x plus 5. That's it. That's a nice, easy shortcut method. Method 2, the factoring by grouping, or AC method, would work even if a wasn't equal to 1. So let me show you guys how to do that. We should get the same answer at the end. So we start out very similar, but the main difference is we have to look at the coefficient on x squared. There's no coefficient looking there, but remember, that's really a 1 there. So we have to do two numbers that multiply to 1 times 15, which I know what you're probably thinking, isn't that just 15? It's the same thing as before. Yes. And add to that middle number of 8. So now we list the multiples of 15 like we did for the previous method. They add to positive 8, so it's going to be 3 and 5. And here's where it's a little bit different. So we now have x squared plus 15. And what we do is we split up that 8x. And we split that up into plus 3x and plus 5x, the two numbers that are right here. You could do plus 5x and plus 3x. The order does not matter. And from here, we call it factor by grouping because we look at the first two terms and we look at the second two terms, and we factor them by each group. So if you look at the first two, our GCF here is going to be x, and then what's left over is x plus 3. And you look at the second two, our GCF here is 5, and what's left over is x plus 3. You should be like, oh, wait, I see it because we have x plus 3 here and x plus 3 here. So that's when you know you actually did it correctly. When you have, and it is actually factorable, is when those are the same factors. So you can take out an x plus 3, and what's left over is x plus 5. And you see, that is the same exact answer as method 1. This takes a little bit longer, but it does expand that method to when a is not 1. It still works the same exact way. So what I want you guys to do is to just pause the video and try the next two and play it once you're done. So this is what we should have gotten for the next two. One important thing to note is that, yes, we have the same factor, x plus 4 times x plus 4 is the same thing as x plus 4 squared, but this is more simplified, so make sure you write it as x plus 4 squared. Let's go to the next page. So I want you guys to try this next one, the x squared plus 6xy minus 55y squared. It's not as bad as it looks, so pause the video and play it once you're done. So if you look at it, we have x squared and then x in the middle and y squared at the end and then y in the middle. So we can do, and then the lead coefficient is 1, so we can still do our shortcut. So we can still look at two numbers that add to 6 and multiply to negative 55. So, I mean, negative 55, the only factors we have is 1 and 55, and then also 5 and 11. And it's adding to a positive 6. That means the negatives have to go on the smaller factors. And negative 5 and 11 add to 6. So what we would do for the shortcut method is that would be x plus 11 and x minus 5. But if you're wondering how those y's affect this problem, the y's just go on the 11 and the 5. And you could see when you multiply it back out, so that's our answer. But if you were to multiply it back out, you would see you would get x squared minus 5xy plus 11xy minus 55y squared. Then you can combine like terms and you get what our original expression was. So you could do that way, or you could do the method 2 from the last page, the factor by grouping. And the way you would do that is, I think this way might be a little bit easier to think of for this one, is it's all the same steps pretty much in the beginning because our lead coefficient's 1, so we do 1 times 55, negative 55, and we get negative 55. So we want the two numbers to multiply to negative 55. So we choose our same numbers, negative 5 and 11. But the only thing we do differently is we split up that 6xy, so we don't automatically go to the shortcut method and getting the answer right away. So we would have x squared stays here, minus 55y squared stays at the end, and then we split up that 6xy with our two numbers, so minus 5xy and plus 11xy. And then we can do our factor by grouping. So greatest common factor here would be x. We're left with x minus 5y. Greatest common factor here would be positive 11y. We're left with x minus 5y. Look at that. We have the same thing here inside the parentheses. We can take that out. X minus 5y, that's our GCF. And what's left over is x plus 11y. And that's the same thing as we did with the first method. So either method works. So looking at A, B, C, and D, I want you guys to read over the A, B, C, and D, pause the video, and then play it once you are done. So all this is really doing is concentrating on the signs of the factors we find, which would be H and G, H and G. So it's asking us about essentially the signs on H and G's. Are they positive or are they going to be negative? So if their C is positive, so the number they multiply to is positive, and the number they add to is also positive, greater than 0, then if they're multiplying to a positive, they have to have the same sign, but they're also adding to a positive, means both H and G are both positive. And similar to B, if we're multiplying to a positive for C, that means they have to be the same sign, but they're adding to a negative. That means that they both have to be negative numbers. And that's what this is saying. It's going through those rules of factoring. And if C is negative, so we're multiplying to a negative, that means they have to be different signs. And B is positive, that means the factor with the larger absolute value is going to be positive because the positive is outweighing the negative. We're adding to a positive. And similarly, if we're multiplying to a negative, different signs, but we're adding to a negative, that means the factor with the greater absolute value is negative because the negative is outweighing the positive there. Let's go to the next page. So difference of two perfect squares. It's always when it's a two perfect squares, so two perfect squares, and difference, so we have to be subtracting. So it's when it's a binomial, two terms, both terms are perfect squares, and we're subtracting. There's a shortcut to do this. So what you could do for a difference of two perfect squares is you want to think of the square root of each of the perfect squares. So that would be x and that would be 8. So how you would factor this would be just x plus 8, x minus 8. You change the signs. That's it. The reason being for that is, so if we have x squared minus 64, think of what's going to be the middle. The x is going to be, well, it'll be 0x because there is no x there, so it cancels itself out. So 0 times x would be 0. So You can do what we have been doing for factoring before if you want to do it this way. Two numbers that add to 0, multiply to negative 64, would be 8 and negative 8. So it'll be x plus 8, x minus 8. So that's the whole reasoning behind that little shortcut. I just want you guys to pause the video, play it when you're done, and do the next 3. So this is what you should get on for these 3. Feel free if you want to check your work, multiply it back out, and you should get the original expression. Let's go on to that last page. So putting everything together, we're going to have to do a lot of, sometimes for some questions, we have to do a lot of different factoring strategies. So, but the first rule you always want to do is you always want to look for the greatest common factor first. I can't stress this enough. If sometimes you don't take out the greatest common factor, you can't do anything after it. You can't do anything other than that first. And then you can keep going. But you really got to make sure you take out the GCF first. So what I want you guys to do is try the next 2, pause the video, play it when you're done, and we'll go over it. So for the first one, always, always, always look for the GCF first. Does this have a GCF? Well, they're all even numbers, so we can just take out a 2. And then they all have x's, so we could take out an x. And what we're left with is x squared minus 4x minus 21. And don't circle that yet, because we might need to factor this further, which we can. 2 numbers that add to negative 4 multiplied to negative 21 would be negative 7 and 3. So that would be, don't forget the GCF out front, keep writing it, 2x, x minus 7, x plus 3. And can we factor that anymore? We can't. So that would be our answer. And the last one, make sure always first check for a GCF. This is one where they're not different to 2 perfect squares yet. So we wouldn't be able to do that yet unless we took out a GCF. So our GCF here is 8. We're left with 9x to the 4th minus 1. 9 is a perfect square. X to the 4th is a perfect square. 1 is also a perfect square. It's 1 times 1. Don't forget, that was an easy one to forget. And then we're subtracting. So this is now a difference of 2 perfect squares, and we can keep on going. So that'd be 8, 3x squared plus 1, 3x squared minus 1. Can we keep going? Ooh, I see a difference here, but perfect square, not a perfect square. So this would have to be our answer. We cannot keep on factoring that. And that's it for factoring.